All right, welcome to another podcast. In this episode, we're going to be taking a look at how to explore the idea of regression or finding the line of best fit for a given set of data. So what I have here is two columns of data, which we'll often call bivariate data, bi referring to two, variate referring to variables. So two variables of data. Here in my iPad app, the TI Inspire, I've created one column called Hours Studied, and a second column called exam grade. And then I've entered some data here. At this point, if you want to follow along with me, I suggest you pause the video and then record the data yourself. You can do that by opening up a new iPad file and simply adding in a list in spreadsheets page. So once you're on the list in spreadsheets page, you'll just add in the data that you see now. All right, if you're still with us, what I suggest you do at this point is go over here to the side, and we're going to add in a data and statistics page. So once you add in a data and statistics page, this is where we can create a scatter plot. So you're going to create a scatter plot by adding along the horizontal axis the hours studied, and along the vertical axis the exam grade. Now, this looks like a pretty reasonable scatter plot, and one of the things that we want to get in the habit of doing is looking at a scatter plot and being able to determine the correlation coefficient. So this data looks reasonably linear in that if I looked at a line of best fit, so some sort of linear equation that I fit through the points, that linear equation would probably fit pretty closely to these points. And so it seems like generally a pretty good linear relationship. So I would say this is a strong linear relationship or a strong correlation coefficient, which means we're looking at an R value between 0.7 and 1 for this particular data set. And so what we're going to do in this video is actually verify that guess. We're going to verify that the correlation coefficient is indeed somewhere between, let's say, 0.7 and 1, and we're also going to come up with the line of best fit. One quick thing to mention before we move on to that is that you can look at the individual dots and see, or the individual data points, and see what their X and Y values are. The way that you do that is by selecting Tools, and then if you go to Analyze, you can select Graph Trace. And so you automatically see that it highlighted the point down here at 2 and 56. I can select another point and it'll tell me its value, and so on and so forth. Another way is I can use the arrow keys up in the top right to select various data points and just continue to select those data points throughout. And so that can show me the values of the individual data points. Once I'm done doing that, once I'm done examining the data set, I can just hit X here and graph trace and get rid of that. Now, moving forward with this, what I want to do now is create a line of best fit for this data. And the way that we do that is by going to Tools. And once again, if you're in the Analyze menu, great, but if not, select Tools and Analyze. And then what we're doing here is a process called regression, in that we're trying to fit a function to the data. That's called a regression technique. And so I want to select regression. And what I want to do is show the regression line for linear mx plus b. We know that a line is of the form y equal mx plus b, so showing linear mx plus b is the choice. And the really nice thing here is that it immediately creates for us the line of best fit, and it also creates for us the equation. So you can see out to the side of that line of best fit is the linear equation that best fits the data. It has a slope of about 3.25, 3.26, and it has a y-intercept of about 60.1. Here in a second we're going to analyze what those values mean, but for right now that's our line of best fit. Now the one thing we haven't calculated at this point is the correlation coefficient. In order to calculate the correlation coefficient, you have to turn the diagnostics of the calculator on. And so the way to do that is by selecting the Settings button up here at the top. So select Settings. And if you notice, the option for diagnostics is not turned on. That's the second option there. So if I move that over to the right and turn it on and hit OK, you notice that there's been an extra piece of information added to the screen. And that piece of information is what's called the R-squared value. The R-squared value is called the coefficient of determination. So if I navigate away from this for a second and add a calculator page, I can actually figure out what the R value is by taking the square root of that. All right, so I'm over on the calculator page at this point, and what I want to do is take the square root of that value I just found. So the square root of R squared here, so R squared is 0.852736. So our R value for this problem is 0.923437. So that is a very good linear correlation. It's a very strong positive, those are the words that you should use to describe it, a strong positive linear correlation. The closer it is to 1, the more linear-like the data is. And what that means is, what linear-like means is that for every change in x here being the number of hours studied, we would expect to see a proportional change in y. And that proportional change is the slope, and the slope here is 3. We're going to analyze all of this in a second, but I want you to make sure you understand what it means to have a linear relationship between the variables x and y. Now there's one last thing, since we're on the calculator page, that I want to pass along to you here in terms of calculator operations. And that is, if I go back up to the Tools menu and select Statistics, we've been doing a lot of one variable statistics. But if I select Stat Calculations, since we actually have two variables for this problem, both an x and a y variable, it's probably a good idea to select two variable statistics. So that's what we're going to do. We're going to select our x list to be the hours studied, because that's what we put on the x-axis. And we're going to select the y list to be the exam grade. When you're done doing that, you can leave the frequency list alone, the categories, you can leave all that alone, just hit OK. Now it's giving me a big list of statistics, but let's make sure we understand what they are. The very top value here is x bar, and x bar is the mean of the x list. So that's the average number of hours studied for this particular example. If you look here at SX, SX is the standard deviation, the sample standard deviation. So the standard deviation of the number of hours studied was 3.8239. I can also get the y mean and the standard deviation of the y's. Now those values are the average exam grade and the standard deviation of the exam grades. If you look, I also get 5 number summaries. So you can see my min, Q1, median, Q3, and max for both x and y. So I get 5 number summaries for both x and y. But the thing that we really want to concentrate on here is this R value. So if you notice, we have an R value here of 0.9234. That R value showed up in this list. And so if I scroll back up, you can see it's the same R value if you compare here with comparing here. It's the same R value that we got when we did it graphically. So two different ways to calculate the R value in the calculator, but what I really wanted to do was take a moment, walk you through some of the steps involved in not only creating a scatter plot, but creating a line of best fit, and then using the two variable statistics calculation to figure out the correlation coefficient for the data. All right, thank you for watching. We're going to follow up here in a second with an analysis of these results. All right, now we want to take a second and analyze the results that we got from the calculator. In particular, we're going to record a couple of values here, starting with basically what the calculator gave us. If you look back at the prior parts of this video, we found that the R squared value was 0.852736. And this R squared value, remember, it's called the coefficient of determination. What this value tells us is it tells us that 85.3%, so rounding there, 85.3% of the variability in y. Remember, y here was exam grade. So we can predict that up to 85% of the variability, 85% of the variability in exam grades is, you don't want to say caused, because remember, correlation is not causation, but is explained, is probably the better word to use here, is explained by changes in X, which in this case was hours studied. So this would be the appropriate way to interpret that value. That 85.3% of the variability in the exam grade is explained by changes in hours studied. That's pretty good and pretty reliable as a predictor. In other words, the number of hours you study is pretty reliable as a predictor of your grade. Now, it's not a perfect predictor of grade, but it's a pretty decent one. We then found the R value, if you recall, by taking the square root of this number. So if I take the square root of 0.85 2736, then I got the R value that we obtained in the video of 0.923437. And so this is just called the correlation coefficient. And so we are pretty familiar with this one. This is the linear correlation coefficients. There are other correlation coefficients out there, but R is the one specifically for linear correlation. A couple of other values we were able to pull out that may or may not be useful depending on what we're doing. We pulled out the standard deviation of the x's. That was 3.8239, and the standard deviation of the y's. That was 13.499, along with the means for both of those sets. And so the average number of hours studied was 5.8. The average exam grade was 79. So remember that these statistics are found using the two variable statistics. So these are the two variable statistics routine in the calculator. And finally, the star of the show, the reason that we're doing this, is the line of best fit. So our line of best fit here was given to us by the equation y equals, and we had several things here. We had, I'm going to keep the decimals pretty long here, and the reason for that is that'll increase the accuracy of our answers in a bit. So in general, you want to use several decimal places for this. So we got y is 3.25988x plus roughly 60. Let's make sure that you understand how to interpret this result. This says that for every 1 hour study increase, your grade is predicted. Not that it actually will, but it's predicted to increase by, I'll round it here, predicted to increase by, let's say, 3.3 points. So that's the interpretation of the slope. So this is the slope, m. And then the b value is the y-intercept here. And if we're interpreting the y-intercept would say, if you don't study, then you can probably expect to make about a 60 on the test. So that's your baseline grade in some sense. So what are some questions that I might ask pertaining to this type of material? Well, I could ask something like the following. So the first question I could ask would be, predict your grade if you study 9 hours. Well, basically what this is saying is that if you study 9 hours, then x is 9 and the grade is y, so I want to find y given that x is 9. So I'm just using this equation now, and so I'll solve for y is equal to 3.25988 times 9 plus 60.0927, and I'm basically just going to put it in the calculator at this point. Right, and so at this point, what we end up noticing is once we calculate this value, we're going to end up with, and you should check this for yourself, we're going to end up with 89.43. So this is the approximate grade that you would receive if you were to study 9 hours. Now, the flip side of this would be to find y. So the question I might ask here is, how many hours of studying will it take to make a grade of, let's just go for broke here, a grade of 100. So according to this model, how many hours should it take to get a grade of 100 on this exam? Well, in this case, basically, I'm trying to find x, and I know that y is 100. So I have 100 equals, basically using the same equation here, but I don't know x, and 60.0927. At this point, we would use our skills of algebra here to solve for x. And if you solve for x, and you should verify this at home, you get 12.24. So this is the number of hours. So always be aware of units here. This is the number of hours, and this is the grade, which typically we think of grades as percentages. So two different problems, one solving for x, one solving for y, but this is the type of analysis that I would expect you to do for a linear correlation problem. All right, thank you for watching.